Fantastic. Oh, welcome, Lithuania. Illinois, Hawaii, Prattville, South Carolina. Is that Prattville? I wonder if that was Prattville, Alabama. I'm not sure. Okay, my clock is reading 12 Central. Welcome to the Tree Fund webinar series. It is a pleasure to be back. My name is Bo Broadbeck. I'm an extension specialist at Auburn University, and it is our pleasure to once again be hosting the Tree Fund webinar series in 2022. I serve as chair-elect to the Board of Trustees at Tree Fund, and Monica and I have been working on this webinar series for a number of years. And so it's great to be back. It's great to continue. I love the diversity. As always, this webinar series was created as a means to share some of the new and emerging research that is being funded by Tree Fund. So we have another great presenter for you today on another topic that was funded just a few years ago. So some of you may not have heard this topic before. To give you all an introduction to Tree Fund and to welcome today's speaker, I have a fellow trustee with me, Rachel Barker, who's been on the Board of Trustees now for almost 2 years and works with Arborimetrics. And so, Rachel, I will turn over the virtual floor to you to tell us a little bit about Tree Fund and also introduce John Goodfellow today. Thank you.
All right, thank you, Bo. Can you see my second slide? There we go.
Looks great.
Yeah, there we go. I am Rachel Barker, as Bo said, Tree Fund trustee. Work for Arborimetric Solutions, managing the project management office. So I'm happy to be here today. This webinar is presented by the Tree Fund. We have a schedule of our 2022 webinars here on our website at treefund.org. Next month, please join us for a presentation from Andrew Hirons, who will present his research on enhancing the performance of urban stormwater management schemes with tree selection, mainly developing a new approach to assessing waterlogging tolerance of temperate trees. So that will be very interesting. Tree Fund is committed to exploring and sharing the science of trees and how they contribute to our lives, our communities, our economy, and our planet. With these webinars, the Tree Fund gives you an opportunity to learn the emerging knowledge gathered from the Tree Fund supported projects and an opportunity to earn free CEUs. With that being said, your donations, if you can make donations, these are what help us to continue to do these type of things. So if you could donate at treefund.org or follow the link, Monica is now going to post in the chat box. So your support of Tree Fund and these webinars does make a difference. One last housekeeping note before I introduce our speaker. In accordance with ISA and SAF guidelines, the Tree Fund will submit your name and certification number to ISA and or the SAF for your CEU credit. If you have not submitted your certification number during registration, please email that to treefundwebinars@gmail.com with your name and certification number. You must watch this webinar in its entirety to qualify for CEU credits. And please note that starting this year, ISA is implementing a global download of attendance list for your CEU. In order for your ISA CEU to be processed correctly, your ISA certification number must be formatted correctly in regards to the dash placement and corresponding credential letter. So you'll see that there, such as IL-OOIT. So be sure you do that right. So with no further ado, I'm going to introduce our speaker today, John Goodfellow. He has over 40 years of experience in the utility industry, having held positions of responsibility for vegetation management, T&D operations, maintenance, engineering, and construction at 3 electric and gas utilities. Mr. Goodfellow is recognized as a leading authority on utility vegetation management and reliability. He currently manages an active portfolio of vegetation management related research projects focusing on electrical characteristics of tree conductor contacts, tree biomechanics, and integrated vegetation management. practices. John worked directly with the National Arbor Day Foundation in creating Tree Line USA program, which recognizes utilities for excellence in maintenance and construction activities in the urban forest. He also worked to create the Right-of-Way Steward Accreditation Program and serves as chair of the Technical Advisory Committee of the Right-of-Way Stewardship Council. So with no further ado, I'd like to welcome John today, and this will be a great webinar. One note I did miss, if you have questions during the webinar, please put them in the Q&A box. If you want those questions for Mr. Goodfellow to answer at the end, we'll be able to select from some of those. So please put your Q&A in the Q&A box. So John, over to you. I'll stop sharing my screen.
Let's see if we can get this to share. All right, I presume you see a cover slide, is that correct?
Not quite yet.
Should be loading up.
There it is.
All right, great. Well, I'm really pleased to be here, everyone, and appreciate your interest. This is a challenging project. There's three different ways that you can think about economic analysis. There's least cost analysis, there's least cost efficiency analysis, and there's benefit cost analysis. In terms of hierarchy, the gold standard is benefit cost analysis. It requires a level of detail in the data that is really hard to achieve. And we'll get into the specifics there. So I just want to first say this project evolved as I went through it. I'd like to also acknowledge the team. So Dr. Mahan at Penn State and one of her grad students, Grant Wills, did the heavy lifting on the literature review to a large extent. And there is a paper that goes along with this. And Tree Fund has made the report available, and it has all of the citations. There's, I don't know, 50, 60 different citations. I didn't include those citations in this presentation, but I did indicate where the literature does support what these analysis project. And then Dr. Charlton, Phil Charlton, a good friend, did a lot of the analytic modeling. So let's see here. I'm gonna get over here like that. The project really is a continuation of a project that I began with Dr. Nowak and Wagner at SUNY ESF in Syracuse. And that project was done for the SIATE Institute, and it looked at the least cost of IVM, or integrated vegetation management. And this project is an extension of that, as I said, and we got additional support from PG&E and Corteva, which is now rebranded Dow Ag Sciences, and Aspen Tree Expert Company. So with that, let's talk first about what IVM is, Integrated Vegetation Management. Why do we do it? So there is a standard, ANSI 300 Part 7. There is a BMP recently published. It's the 3rd edition, and it codifies what IVM is. But the reason that we're even interested in this is it's a sustainable means of managing rights of way. And by that, I mean, we seek to establish a cover type that is essentially occupying the site and suppressing the reinvasion by tall growing or incompatible plants, trees in this particular case. So the project was set up to look at two approaches. One is the IVM-based strategy that looks at, so the I in IVM is integrated. So it's a collection of different vegetation maintenance techniques, including the use of herbicides delivered in a number of ways, as well as physical controls such as hand cutting and mastication with the forestry mowing equipment. The key is that it's an active strategy to manage the right-of-way corridor for a community of compatible plants to the disadvantage of tall growing trees. And that's compared to a simple strategy which relies on repeated physical control by mechanized cutting of vegetation. This particular image on the lower right comes from, I believe, South Carolina. where the two strategies are in play on a right-of-way owned by two different companies. So before we get into the analysis, I got to lay some groundwork. A couple things that we designed the project around. There's both a short-term and a long-term impact or effect of these two different maintenance methods or approaches. And they are based on terms of how immediate the impact and what is the longer-term impact. So so we've got two techniques, IVM and mechanical or non-IVM. We've got two time frames. And then when we started to look at what kinds of data were available, we soon found there were a great number of limitations. So this little table down on the left basically sets up the durability, perhaps, I don't know if that's the right word, but the reliability perhaps of the data. And the gold standard is ratio data, and the least rigorous and softest, if you will, are nominal data. So let's think about what those are. If it's a nominal data, it simply has labels. The next level of rigor is ordinal data. So you've got a ranking. The labels have rankings, they have meaning. Then you've got interval data where the difference between the rankings actually is a metric, it's quantifiable, means something. And ratio means that you've got interval data with a zero reference. So dollars, when you talk about monetizing these things, dollars has a zero and the value between the observations have meaning. In contrast, some simple scales simply imply an order, but do not have values between them. So on the right, we looked at those different attributes: economic, safety, operational, risk perception, nuisance, site impact, vegetation, and wildlife. And you can see that we were not able to do cost efficiency analysis with most of these things. So as I said, the project evolved over time. And I'll show you the specifics on each one of these. And we had to rely on ordinal analysis. And again, if you think about what that is, it's labels that have an implied meaning between them, but not a value. And this is the last slide setting this whole thing up, because I think it's really important for you to understand the limitations, frankly, of the analysis. So I mentioned this ordinal approach, and many of the cost factors, we could only achieve an ordinal kind of evaluation. And so what we did to get that was to basically do a survey of practitioners. Within the Utility Arborists Association, there's a group of senior members, and at that time, N was 142, when we got 26 respondents. So, 18% is pretty good. We developed these, it's called a Likert scale, but basically bipolar adjectives. If you can look at them, you can see significantly worse, significantly better are opposites, but have the same value. And I used a little simple rating system of double pluses and double minuses and zeros when I'm scoring things. The second approach was what we did a couple of years ago with that SIATE study, where we did least cost analysis. And the importance there is that we can turn all of the observations into monetary terms. And so we're dealing with ratio data at that point. And we can use economic methods to come up with a least cost conclusion. Cost effectiveness analysis goes a step further. You use the least cost analysis findings, and then you compare them to the benefits. And this is often called a ratio kind of analysis as well. And it uses ratio data. And the thing here is, we can't get to true benefit costs because the benefits can be quantitatively stated in terms of abundance of pollinators, for example, but we can't put a dollar value on that. So that's a limitation, and you'll see how that plays out here. Finally, I had to come up with some means of describing, shall we say, the reliability or the rigor of the data sources. And so my 3 Ls. The literature is the highest and best reference, and we did find some really meaningful papers, but frankly, they are quite limited. We then also applied logic, and it basically is deductive reasoning, knowing the issues and thinking about it, and come up with a projection, and it is opinion at that point. And then we couldn't come up with another L other than lore, but this is the input from the practitioner surveys, and that was largely that ordinal data. Okay, so I just laid the foundation, and it's complicated, I will grant you that. And we'll go through each one of these, and I will also say that at the end, I've included one of the appendices to the report, because we'll get into the least cost analysis in some detail, which is the floor to all of the analysis. But essentially, when we did least cost analysis, the very simplest approach, we just went head to head with 2 strategies. After a right-of-way is initially cleared, so none of the cost of clearing, because that would be the same in either case, we brought the cost structures to maintain that right-of-way forward in time over a 20-year horizon, and then basically came back with the present value of those costs on that 20 years horizon. And you can see we used a 5% discount factor, which is pretty consistent essentially with what the industry is using right now. Now, here's the answer. As I said, in the appendix, to the last 20% of this presentation, we're going to get into actually how these numbers are derived. But when we ran the least cost analysis and we compared the 2 methods, you can see some pretty important things. First, if you're a bottom line kind of person, you can see the difference in the present value of the 2 strategies, $1,400 versus $3,000. Operationally, and you can see why this might be, the stem densities are much different after repeated treatments. And also, interestingly, the height of the plant material, the incompatible trees, is quite different as well. So down on the lower left is my little 3L table. You can see the literature was somewhat limited, but we did find, I think, 4 different references that projected IVM strategies on varying time horizons, plus or minus 20 years, on the order of 40 to 50%, which lines up pretty well with the calculations that we made here. And then when we do least cost analysis using the logic, we definitely have demonstrated value. On the right, what this tells us is simply that the difference between the work that I did for SIATE and this project, the cost structures were changing. And this is not all that important, I think, to the presentation, but it's on the slide. So essentially, it says that over those ensuing 3 years, the cost of herbicides didn't change a lot, but there seemed to be consensus amongst practitioners that the cost of mastication or mechanized clearing went up pretty significantly. Okay, safety. Now we're going to break safety down a couple of ways. Safety of the general public. Remember, now we're comparing the 2 strategies, mastication versus the application of herbicides. Under the literature category, there's nothing in the literature that I could find that had anything that was useful that describes the safety of the public associated with either of the 2 maintenance strategies, vegetation maintenance strategies. Logically, you could say that the cut stubble remaining perhaps creates somewhat of a hazard, so I gave it a single plus. Practitioners came down resoundingly in favor, saying that the IVM strategy was significantly lower risk. If we want to go to the safety of the workers, there are data available. So OSHA maintains a couple data sets, and there are standard industry classifications. As we looked over those definitions, we picked 4 that seemed to line up pretty well. Looking at these titles, you might think, well, maybe they don't line up well, but if you get into the details of the definitions, works out okay. And then within each one of those 4 SIC codes, there are these classifications, and we picked 3 classifications that we thought mapped pretty well into either an IVM strategy, a mechanical mowing strategy, or a hand cutting strategy. Survey says, here are the results. Two different cuts at this. On the right-hand side, upper right, are injuries. On the lower right are fatalities. You can see the time horizons are different. They're two different data sets maintained by OSHA. I don't know why that is, but they're different. Also, I would say there is as I was preparing for this, I reviewed the report and there is an error in one place, not consistently, but for some reason I put 3 extra zeros in the report at one reference to the OSHA data, and it says 200 million. It's not. It's 200,000 hours, and then there's 2,000 hours roughly in a work year, and so it's the equivalent of 100 full-time equivalents per year, is what these data are reporting. You've got days away from work, and then you've got, but then they come back to go to work, versus the DART, days away, and then they come back on restricted time or transferred to a different job. So a more severe injury, and then the total case rates. And if you look at the results, you see that herbicide applications versus the mechanical are coming up with a higher total case rate, well, actually across the board on each one of those metrics. And when you throw the hand cutting back in there, which is part of the non-herbicide technique, it will pull those numbers up, but I didn't try to combine them. I thought that would be implying precision that you couldn't sustain. Same kind of thing on the lower right. The mechanized mowing comes up with lower numbers, and it suggests that then there's significantly less risk. Some reasons why that might be is the mowing equipment, generally the operator is in a cage, which protects them. Not always, but that's the only reason I could come up with to think why this might be different, because intuitively it didn't make as much sense to me. That's what the data say. If we go to the practitioners, you can see that the practitioners felt that there was significantly lower risk, but they're offset by almost the equal percentage. If you think equal risk is the middle ground, right? There's 40% on both sides of that. So pretty inconclusive. And it lines up with essentially, we couldn't pull a lot of insight from the OSHA data. But what at the bottom line is that according to these data, the non-IVM strategy might be less risky to workers. Okay, operational risk. This is where this 2 time frame thing comes into play, and it's really quite important if you think about it. If you're if you're trying to abate the risk of an incompatible causing an electrical short from a transmission conductor to earth, then the short-term interest is paramount. And then over the longer term, what does it mean? Well, it means that the likelihood of that happening is that different under the 2 strategies. And so if we look at the table down below, really there was no literature on the short-term risk, but logically the short-term risk is immediately abated with any strategy that physically controls the incompatible plant. And so that would put the mechanical or non-IVM strategy at advantage. And then if you look at the fact that under the IVM strategy, the stem densities come down and the height growth rates drop, then you could make the argument that longer term there's a benefit. And the lore, if you will, from the practitioners was a very strong conclusion that first, if you look at the wording on the upper right, effectiveness of IVM treatments mitigating operational risk as compared to mastication, and then the longer term down on the right. You get an idea of what the practitioners felt. Okay. All right, public perception. So this is clearly very qualitative. There was no literature that I could find at all on the perception of the public following either operation. Now there is literature, turns out, for line clearance pruning in urban areas. There's at least one paper in the Journal of Arboriculture from the past that looked at the issue of the public perception for line clearance work. And I should say, one of the sources we looked for, we looked at environmental impact statements when we found a fair amount of information on some of these techniques in that that genre of literature. But we didn't find anything specific to these techniques in this regard, public perception. And then the logic pretty much says that, it's highly qualitative again. I couldn't come up with logical arguments either way. You can make them either way. And then short term, there might be some concerns, frankly, with the application of herbicides. But over the longer term, what we see from the feeling of the practitioners is that there's more favorability because things like it's less intensive work. It's not bringing a big machine in to mow every 4 years. It's coming in and selectively removing fewer and fewer incompatible stems over time. So, and then I thought we asked the question also of the practitioners. Well, okay, the public and your customers is one constituency. What about the regulatory staff? This is the chart on the lower right. And there was a feeling that IVM, the Integrated Vegetation Management Strategy, was favorably perceived by regulatory staff, which is important to a regulated utility, of course. A recreational use of the right-of-way. So this is things like trails and going for walks and whatever. And there are a couple things why this might be have an impact. Certainly, there's the heavy operations, the cutting operations leave a cut stubble, and there is perception of amongst the public of the health risk of using herbicides and also the aesthetics of the brownout, if you will. And so what did we find? Well, here again, there's very little, we didn't find anything, frankly, on multiple use of rights of way as related to maintenance techniques. And there's a literature out there that's talking about how valuable multiple use of these corridors is, but there was no references to the comparison of maintenance techniques at all. You could logically say that, again, I've made this argument a couple times, as a cover type matures, compatible cover occupies an increasing percentage of the site in suppressing the regrowth or reinvasion of trees, that there will be less disruption and therefore less limitations on the right-of-way as a place to recreate. And the users felt essentially the same way, that shorter term, you'd see fewer limitations, and longer term, even fewer. So, and what about aesthetics? We're really close to the same issue, but we were really clear when we framed the question. Recreation was recreating. Aesthetics is the visual impact. And so once again, there's no literature. I mean, it's just not there, but logic tells you that there's a visual impact, and immediately there is an impact. Either it's radically altered because it's all cut down, or it's turning brown. And so there was no, I rated it 0 because I couldn't logically argue one was better than the other. If we look at the practitioners, they essentially kind of came down the same way, that there's not a strong difference immediately on the aesthetics, but longer term, there's a very significant difference as the IVM strategy deals with less and less intensive maintenance practices. Another question about the impact here. What about public nuisance? Well, in this case, nuisance really deals with odors, noises, things like that. And you could say that there's noise associated with heavy machinery operation, certainly, and there's odors associated with herbicide use. Once again, the literature provided no useful references. The logic kind of says they almost self-cancel, and the IVM treatments would really probably be lower, I think, because most of the herbicides now are relatively odorless, and you're not going to even be aware that it's going on unless you happen to be there, as opposed to the big machinery does create quite a ruckus, if you will. And the practitioners came down very strongly on that point, that the IVM strategy had less of a nuisance impact. And remember, what I'm just saying is nuisance. It's a technical definition of things like noise and odors, not inconvenience. Okay, now we're getting into some closer to the environment. So these data largely came from environmental impact statements. So we're going to look at the environmental impact, and there's two cuts here. One is the soil disturbance associated with, and one is the impact on water quality in water. And so if we have this comparison and thinking about the mastication equipment, it's bigger machines, taller stems, potential to create ruts or compact the soil. And the mowerhead getting down into contact with the soil surface, it's a bad practice, but a lot of operators like to do that because they think it looks like a good, clean job, where the better job is to leave the cut stubble a little bit ragged. So you're not creating a seed bed and you're not disturbing the soil surface. The IVM methodology doesn't require large machinery. Often the work is done with backpacks, guys on foot. And with each treatment, the disturbance drops further and further. So there were literature, this was literature in environmental impact statements on some of the national forests that looked at these issues head on. And you can see how we scored those things. Basically, logically, the potential to disturb the soil is quite a bit less with the herbicide treatments under most of the methods that the application occurs these days. Just as a footnote, I just finished a project for EPRI where we looked at the types of applications being made, and 70% of the acres on the North American high voltage grid are being maintained with low volume foliar applications, which are people walking with backpacks on their backs. Very little high volume foliar with bigger machines and big spray tanks. So that was borne out subsequent to this study. The practitioners pretty much agreed with that analysis, saying much less, significantly less disturbance associated with the IVM method. You look at the water quality. So this assumes that appropriate protection measures are maintained in riparian zones, whether it's restricting equipment operations and or restricting application of herbicides and leaving buffers. And as I've said just a moment ago, those same impact statements describe soil disturbance as the major concern with water quality. And so we gave that a plus from the literature, and similar logic basically to the soil disturbance. Okay, now we're going to get into a little more quantitative data. This is the stuff that gets me excited, I have to say. So controlling the incompatible plant pressure. I'm using the word plant pressure because IVM is an adaptation of integrated pest management. And in that domain, pest pressure is the way you describe this. And so what we're looking at is what happens under these two strategies to the plant communities. First, we're going to look at the incompatibles, and then we're going to talk about the compatible cover. Well, the literature is actually quite a bit more robust in this regard. What it does is provides a solid basis of changes in stem densities, but remarkably, and we found this in the first project, very, very little reference to height. And when I talk to the practitioners and the applicators, it's really clear that this is a volumetric kind of decision. In other words, height and density matter. And you can intuitively think about why it would, because it's the target that you're having to maintain or to control. And so we went back to the literature and found some additional references, and were able to improve the production functions. That's what these two graphs on the right are called in terms of economics. There's a density production function and a height production function. And we were able to tune those up to a greater degree. And I'm going to just go right ahead to show you something. So don't take my word for it. I mean, this is really, this is probably the best data that I've ever found that supports these ideas. I want to help you think about how to look at this. So you see the colors across the bottom. Those are high, medium, low, very low, ultra low, and not applicable. So set aside the blue bars. So if you're if this is the density of incompatibles on rights of way in New York State on the New York Power Authority system. This is a 345, 500, 765 system. These are big, wide right-of-ways. They are maintained on a 4-year cycle, and they were maintained religiously on that cycle, and they acquired a great deal of data when they laid out their work. So what you really want to look at is, for example, the dark green bar. That's the ultra low volume or density category, and the middle green bar. So what you see is the really heavy and medium densities consistently being reduced, and the very, very low and ultra low densities substantially increasing over time. So that proves out that production functioning on density. And we use these data to build that production function and other data. This is I think more remarkable, frankly. This is a data set that no one really has until recently. And so look at what's happening. Every 4 years, the incompatibles are not only becoming less abundant, but they are becoming shorter. And why is that? Because the compatible cover is suppressing the growth response of the trees. So there is a demonstration of the biological control method operating within the IVM construct. We were able to significantly suppress the height growth response, and that's what causes the risk to the power system. All right, so up until recently, IVM has been all about controlling the incompatibles, but we are, as an industry, increasingly committing to the idea that, if you can see this quote right out of part 7 in 2019, the reason for IVM is to create, promote, and conserve sustainable plant communities that are compatible with. In other words, we're managing for something. If we look at the literature, there's some, but most of the literature still only talks about the trees we are controlling, the incompatibles, and it makes reference to the plant communities and cover types that are suppressing the height growth response, but it's not directly addressed. It's part of a bigger discussion around the suppression of the trees, either in abundance or height. Logically, we know why this would be. Their herbicides are essentially effective in eliminating a plant from a site, as opposed to controlling the above ground portion. And the practitioners effectively are in that camp as well. So, all right, now we're finally going to get to what this report was about, or this project was about. That's the cost effectiveness analysis, because what I've been doing so far is I showed you a little bit about the least cost, but mostly we've been doing basically pretty soft analyses. It's hard to call it economics even. But now we're finally going to get to the cost effectiveness analysis. And what that really is looking at is we've got our two strategies. We've got IVM and we've got the simple mastication or hand cutting. In other words, non-using herbicides. The costs are known, and we've got those because we were able to do the least cost analysis. And so and those costs can be converted to avoided costs, and they become benefits. The other benefits are qualitatively stated, but you can't monetize them. And those data come from the literature. And what do I mean by those data? We're going to look here shortly at white-tailed deer. We're going to look at various avian species. We're going to look at reptiles and amphibians, etc. You can't put dollars on those. The other complication, and this is the paragraph on the upper right, is that while a right-of-way is a substantial area of land, it typically isn't all that wide. And unless these critters don't have much of a range, there is much or more influenced by the habitat adjacent to the right-of-way than they are to the cover within the corridor. So it makes for a challenging analysis. Okay, benefit to whitetail deer. This is, as I said, this is the cost efficiency. I'm going to walk you through how this works, and it's not intuitive, but it makes sense once you get your head around it. So if you look at the column that says present value cost 20 years per acre, and you've seen these numbers before. After 20 years, bringing the cost back to year one, $1,412 to maintain that acre under an IVM strategy with integrated tools and covers changing, et cetera, versus $3,114. Okay, that's the easy part. So there is literature, and in the report, if you're really interested in this, you'll see the citations to this. But there's study, Penn State, Game Lands, basically uses a, I guess it would be a ratio scale because there's zeros, but not in this bandwidth. It's 1 to 10. So what they were rating or scoring the habitat on right away that were maintained by use of herbicides and ones that were only maintained using mechanized cutting and hand cutting. And so the score is a deer per acre. It's just that the quality of the habitat under the herbicide was 7.1 on a 10-point scale. Quality of habitat under cutting was 7.5. So first blush, you see that the habitat is 4/10 better on a 10-point scale. So that's sort of implying precision. They're pretty much close to each other. But if you apply least cost analysis, you get to that 7.1 much less expensive to get to 7.1 than it is to get to 7.5. And so by cost efficiency analysis, or you get 200+% efficiency, economic efficiency under the IVM strategy. Let's look at birds. There were at least 4 studies that we could actually get numbers out of. And going down the line again, you can look see it would be average numbers. You can see it's diversity or birds, abundance, etc. The numbers are pretty close, often 28.5 to 26, 10.2 to 9.2. Abundance of birds per hectare, 130 versus 142. So that's going the opposite way. And when you apply the cost efficiency technique, every time it's much more efficient economically to get to those results, expressed as diversity or abundance or whatever the metric is, under the herbicide or IVM strategy. Same thing essentially when you look at amphibians and reptiles. I found at least 4 references that talked about the abundance or diversity. And some of these look like they're reporting the same thing. Each one of those lines, abundance of amphibians, diversity of amphibians, abundance of amphibians and reptiles, and diversity of amphibians and reptilian species. Each one of those is a citation. So if you get the full report, you want to know what I'm using to cite these numbers from, that's where it's coming from. And you can see, once again, using cost efficiency analysis, there's no question it's more economically efficient to get to these results under a IVM strategy, if that's your purpose. Similar results with butterflies. And I can say that there's a lot of good work. Carolyn Mahone at Penn State and others are doing a lot of work now with pollinators. I expect that we're going to have better data, but we found at least 2 references that allowed us to compare IVM versus hand cutting on butterflies. So generally, if you buy the economic efficiency argument, the literature supported the comparison and we were able to show a benefit. Cost efficiency quantified that. You notice all of those percentages were significant. I mean, they were like over 100% more efficient. And the practitioners felt that that lined up, but the practitioners' results weren't as strongly stated as in some of the other values we looked at. Okay, so now we're going to get into hardcore economics. And this is the least cost analysis that's the underpinning of the cost efficiency analysis. So what we did was we took, and this is an appendix in the paper. We took the analytical model we built, Chris Nowak, John Weber, and I at SUNY ESF built, and tweaked it, updated it. We got better height growth response numbers, so we got a better production function. And Phil and I were able to come up with ways to make it do tricks, if you will. The simple one is, let's just do a fixed interval cycle. And in that case, you saw I used basically every 4 years over a 20-year horizon. We also built it so you could use a user-defined interval, so we could vary the intervals. And we designed it so that we could do on condition. And this is really important. We are able to use action thresholds coming again from IVM and its relationship to integrated pest management. Use action thresholds and tolerance levels to figure out when optimal maintenance interventions occur. We did this for 3 different cases. One is pretty much the simple one. After the right-of-way is cleared, we just went head-to-head with IVM versus mechanized clearing. We did a reclamation case where the right-of-way had been cleared, but maintenance had been deferred, and we were going to bring the right-of-way vegetation back under control. And we were going to do that either with the mechanization, the mechanical cutting, or an IVM strategy. And the third case was, what happens if you have a program that's based on IVM and for whatever reason you lose the use of herbicides? So you saw that. We saw these data before, and I'm not going to spend a lot of time with this, but essentially what happens is you initially have to use herbicides, and you don't under the mechanized treatment. So first cost is higher, the green line, and it pretty much drops over time because of the reduction in stem densities and heights. So let's see how vigorous or how rigorous that prediction is. So we said, all right, let's just say if our assumptions are wrong. What if the IVM method was, let me get this right because this is part of using assumption method. Yeah, okay. So basically this says if the density of the stems on the right-of-way aren't following our production function that predicts that, and let's say they're a lot higher, what does that do to it? And then we did the other. What happens if it's a lot lower? And you can see the base case is the standard version. If the stem densities are 75% heavier than our model would predict, we still have a significant advantage. And if the stem densities turn out to be lower, in other words, the methods, both of them are more effective, we still are seeing a big difference in the cost comparisons, present value cost comparisons of the two methods. So that says that, even if we're wrong with those production functions, we're pretty sure that the argument is very solid, that IVM is much less expensive on a least cost basis. So then we decided, let's test it even further. What if mowing turned out to be more effective? Or what if the herbicide treatments tended to be less effective in terms of controlling? And you can see the effect here as well. If mowing is more effective, then it really comes down in cost from, remember, 3,114 down to 1,807. And if the herbicide treatment is less effective, then it gets more expensive, from 1,412 up to 1,706. But in both cases, again, you see that we are demonstrating that on a least cost basis, the IVM strategy is less costly. So I said we built this so we could look at the impact of time between treatments. And here are the results. And this is really quite interesting. If you look at the two strategies, mechanical, the longer you wait, the cheaper it gets. That makes sense, doesn't it, right? Because you're doing it less frequently on a 20-year horizon. But with the IVM strategy, the longer you wait, it gets cheaper until you get to year 5, and then it starts to get more expensive. And that's because the volumetric aspect of the cost of treatment, right? The stuff's getting bigger. So you can see there's this model with these assumptions, we're projecting a 5-year optimal. We've subsequently done a project for EPRI that goes into more detail on that. Also, look at on the far right, look at the height differences, right? Those are important. That's really quite important. So you're treating when it's shorter under the IVM. The incompatibles are not as tall. In other words, they're less likely to violate a minimum vegetation clearance distance. Okay, so a little bit more on that. So what we did in on condition is we picked a 230 kV right away. Under the National Electric Safety Code, there is a minimum ground clearance for the conductors that must be maintained, and it varies by site. So we use the forest and agricultural site. And then under FAC 003, there is a minimum vegetation clearance distance for 230 kV. And we subtracted those, saying that would essentially says that conductor is at 21 feet or 22 feet. We take 4 feet off for the minimum vegetation clearance distance. Now we're down at 17 feet, something like that. And then we put into that an action threshold that gives you a trigger point before you do the work. And we were saying we're going to trigger the work at 12 feet. And so you get under a strategy that says forget a rigid time interval, you get a different frequency of treatment. It has to do with the height of the plant material. And you can see it changes the economics, right? So an on-condition maintenance strategy for mowing only drops from, it was 3,114 if you recall. Now we're down to we took $1,000 off. Under an IVM strategy on an on-condition basis, we took $300 off it, 400 bucks off it. Interesting, that's a whole nother research topic of on-condition maintenance, but it should whet, I hope, an appetite for a little more work. So let's look at the reclamation scenario, and I'm getting close to the end here, folks. So under a reclamation scenario, we basically used the mowing curve until we got to what we felt like were more or less steady state conditions. So after 10 years, things were changing, but they were not going to change a lot. And then we applied IVM, and you can see what happens to the stem densities. When you do the economics, basically it was 16% more expensive to do a mechanical non-IVM strategy to reclaim a right-of-way. This one is the loss of herbicides, taking the same departure point at about 10 years after things have stabilized. If you lose the use of herbicides, now the orange curve actually should drop a little bit. It's just the thickness of the line's not showing it, because I will tell you that the literature does support that the mechanized mowing will reduce stem densities over time. But you can see that the trajectory of an IVM strategy takes the densities lower. And excuse me, you can see too that after you bring all the costs back to year 10 from 0, back to year 0 from 10, we're demonstrating a 31% improvement. So that's the end of the presentation. Basically, as I said when I began, the project was difficult to do cost efficiency analysis because the data are what they are. Remember, what we need to do cost efficiency analysis are costs that we can, well, they're monetized, they can be turned into dollars, and those are ratio data with values that have meaning between the numbers and they have a zero reference. And then we have to come up with benefits. And the benefits that we're looking at were deer and birds and et cetera, and we couldn't monetize them. But given that limitation, we could show that in terms of the cost efficiency, the IVM strategy was more effective if that was your measure. And that in conclusion, the standards that are out there are good. ANSI A300 Part 7, 2019. There's a new ISA BMP that codifies IVM. And I'll put a plug in for the Right-of-Way Stewardship Council's accreditation requirements document. Published in 16, it's going to be reworked here, I think, this year. That really codifies IVM in detail. To give you an idea, Part 7, ANSI Part 7, A300 Part 7 is not that many pages. The BMP might be 50-page booklet with illustrations and tables, etc. The requirements document is like 50 pages of dense type. It's very rigorous. It's if you qualify as a right-of-way steward, meeting all those objectives, you're a top quartile, top decile performer. So with that, I only, Bo, I think have less than 5 minutes, but I'm happy to take questions if there are some.
Absolutely, John. Thank you for a wonderful presentation. We do have a number of questions, and let me jump right in since we don't have a lot of time. Let's see here. There's one question here. It says, is the IVM treatment spraying the canopies or basal bark treatments of the stem?
Yeah, that's a fair question. So as I said at one point, I in IVM is for integrated. So it relies on a range of treatments, ranging from the most surgical, if you will, such as like a chemical frill, to a low volume basal application, as the person asked about, to cut stump treatments, to low volume foliar applications, hydraulic foliar applications. And in fact, there is a legitimate technique when you're converting a site to do a broadcast application following mastication. So it's the spectrum of really, really specific to potentially limited use of broadcast. We didn't use broadcast in any of our analysis, but yeah, it's a variety of treatments.
John, there were also a couple questions related to why you selected white-tailed deer.
Yeah.
And maybe not songbirds, and there's also a question related to pollinators and that the connection to herbicide use. Yeah,
it's a fair question. And I did actually, the question probably came in when I was talking about the white-tailed deer, because we did get to all those other things. It's what was available. I mean, it's one of those cameo species, right? And if there's going to be literature on wildlife, they're typically game species. And so that's where it came from. Now, subsequently, I've done some work with turkeys. It was after this project, but it's another game species. So the more robust data sets tend to be those marquee game species. But if you recall in the presentation, we had amphibians and reptiles, plus all the songbirds. So, and I did also mention, and I put another plug in, there's just some exciting work going on by a number of people around pollinators, not just butterflies, but bees, etc. So more to come on that.
John, I think we'll have time for one more. And this one came in, it says mechanical and chemical control tools will both still be needed to manage transmission right-of-ways effectively, depending on the location and condition of the right-of-way and edges. Some deferred maintenance also drives this as budgets fluctuate. Right-of-way inspection and prescription will determine the balance of tools needed and used. Any feelings on how to balance this?
Yeah, well, first I would say absolutely right. IVM does include mastication. and hand cutting without herbicides. And so I probably wasn't clear on that. IVM includes it all, everything available. And that's what you do when you prescribe. You've got this toolbox full of tools. And for the reasons that the questioner said, some places you can't use herbicides, some places you've got to reclaim the right of way, some places it's been deferred, blah, blah, blah. So it's not mechanical versus IVM. It's IVM that includes mechanical versus a strategy that's only mechanical. And the other way to say that is non-herbicide. The way to actually do the work is we're changing. I mentioned this in the presentation. It used to be that we exclusively focused on the incompatible species to be controlled. What were they? How dense were they? How tall were they? What kind of site? And you picked your tool based on that. Now, I hope we're also saying, what do I have on the site to work with? What are the compatible cover types that I want to manage for, that I want to favor, and I don't want to cause collateral damage to by a less selective treatment? So it's a combination of the things I just articulated. You can tell I got some passion around this. So.
That's great. John, thank you for a fantastic presentation today.
Well, let me say what takes more time to tree
Sure.
fund. Tree fund supported some really important projects, mine and others, and we couldn't do what we do without tree fund. So thank you.
Thank you very much, John.
Thank you.
Very much appreciate it. I want to remind everybody this webinar was recorded, will be available. Give us a couple days on the Tree Fund site. There was a lot of data, a lot of charts with this complex study. So if you want to go back, rewatch, check that. Also, if you didn't catch it, in the chat box was the full report. As John said, this is a very big, complex study, and I thought he did a great job covering it for us today. With that, I will conclude. I want to thank Monica Odding, who always helps put together a wonderful webinar experience for us. And of course, Rachel Barker, who helped moderate, introduce us a little bit to Tree Fund. Thanks to both of you for being here today. And of course, John, thank you for taking the time to share your knowledge and some of the results of your study.
Happy to. Everybody be safe.
Yeah, with that, everybody be safe today. I know parts of the country got some rough weather, so stay indoors if you can. And I will sign off until next time when we come back with Dr. Hirons in a few weeks. So to find out more about that, just go to treefund.org. With that, thanks all and have a great rest of your week.
Thank you.
Thank you.